Hi, good evening to all of you. Uh, Welcome to today's webinar. My name is Prithviraj Bose. So let's start off, with today's webinar, and I've got some great things lined up for you. Okay. Now, before I start the webinar, I would like to know, uh, your profiles. Before I ask you your profiles, I'll tell you about my profile. Okay, as I said, my name is Prithviraj Bose. And I have been in the software development domain for nearly 18 years now, and my experience is on programming languages. Is from Java, C, C++, Python, and Scala. And on technologies, I work on the Hadoop ecosystem, and I work on web technologies like REST, and REST, mainly REST. I work on. And also I have a fair amount of experience with databases, traditional databases, RDBMSs, as well as NoSQL databases like, MongoDB and, and Elasticsearch. And, I used to work in companies like NDS and Cisco. Now I'm a freelance developer. And, if you look at the Tata Sky EPG, or if you look at the Airtel EPG, if you have a set-top box at home from Tata Sky or Airtel, the software which is running inside is written by me. I mean, obviously, I was one of the chief implementers. We had a team working on it. So, that's a software which I had developed. So that's about me. And today I'm going to take you through, the Spring framework. Getting started with Spring framework. Now, before I start, I would just like to know, like your profiles. Like, could you please let me know, what in what capacity you work? Like, are you a student, or are you a developer? Are you an architect? Are you a manager? I just want to know your profile. Can you just quickly write your profiles? So that I know what's your background, because that's going to help me, in actually in actually presenting the content. Okay, thank you, Shashwata, for your answer. Can I have the answers from others, please? Well, Varsha, if you are not able to hear, probably it's a problem at your end, because others can hear. Just check your microphone, your connection, all these things. Okay. Okay, great. Thank you very much, for your responses, whoever responded. And I would also like to know, do you have any prior experience in web programming? Like, have you ever done web programming before? Like, have you ever written a servlet? Doesn't matter whether it's Java, whether you've used the Java framework, or whether you've used Python Django. It doesn't matter. But have you ever done web programming before? Maybe Kiran, Nikhil, Saurav, Shashwato, Shivraj, Tahsif. You all can give me your answers. Okay, good. Because I'm just trying to. Okay, so so okay, so that's your profiles. Okay, I've got your profiles. Okay, so there are people, just for the sake of others, we have solution architects, we have Java developers, we have product managers, we have .NET developers, and we have aspirant Java developers, and we also have some people, we also have a person who has some experience on REST. Okay, so good. Good to know your profiles. So I'll try to make it as interesting as possible. And while I carry on with the presentation, if you have any questions, please feel free to ask me, and I'll take them as I go along. Okay. So now what we are going to do today is, we are going to look at, I'm going to introduce you to the Spring framework, and I'm going to introduce you to some key features of Spring framework, like dependency injection, and also other things like aspect-oriented programming. So those things I'm going to introduce you to. Then I'm going to briefly talk about the Spring MVC architecture, and then I'm going to tell you something about Spring with big data. Because these days big data is a it's a pretty crazy fad we have. So everywhere, everybody's talking about it. So I thought, I will also talk about it in the context of Spring, and we'll see what you can do with Spring, in the on the big data arena. And lastly, I have some demos lined up for you, because once you're starting Spring, you will be using it in distributed enterprise applications. So I wanted to show you one simple demo. I didn't want to complicate stuff, but I just wanted to show you a simple demo to display the power of Spring. How easy things are. Okay, so let's start with with Spring. Okay, if you are in Java technology, there are frameworks that helps programmers to build distributed applications fairly easily. So to start with, you have Hibernate or IBATIS. They are object relationship mapping framework. Now the ORM framework, what it does is it basically maps your data objects to database tables. So whatever objects you have in Java, those are mapped to database tables using a specification called Java persistence specification. It's called a JPA specification. Okay, so ORM, I'll just write down here, so that you understand in case you can't follow my accent. So ORM, heavily relies on, JPA. Okay, it's called Java Persistence APIs. So ORM heavily relies on that, and this JPA, what it does is, it glues your Java objects to database tables, and don't worry about how it does, but that's what basically JPA does. And even Enterprise Java Beans uses a lot of JPA. Okay, so that's what Hibernate and IBATIS tools does. Okay, then we have something called a Struts framework. It's again an open source framework. These are all open source, by the way. So Struts, is another web UI framework. So you can use Struts to design web UI, like the views which you have on your web pages. You can use Struts for that. Okay, and actually one of the key contributors of Struts, is a very good friend of mine. He's a British, so he's a very good friend of mine, and he's actually one of the key contributors of Struts. And then we have something called Enterprise Java Beans. You must have heard this innumerable times. And this is Oracle's specification for server-side components for persisting and messaging. If you want to persist, you can use Enterprise Entity Beans, and if you want to do some messaging around, you can use message-driven beans. And if you want to just play around with sessions, you can use session beans. Session context objects, you can play around with session beans. And finally, you have frameworks like Log4j, which is Apache's framework for logging. This is a very popular logging framework because all the Apache projects, they use this Log4j framework. So even if you look at any big applications like the Hadoop ecosystem or Apache Spark, Solar, or any Apache project you see, internally they use the Log4j, and it's a pretty good stuff. It's good to learn. Maybe you can pick it up by yourself. So let's see. When we use these Java frameworks, when we are using these, so what happens is, one of the problems is the applications, that use varied frameworks and services, face scalability issues, mainly, in terms of, when they interact with each other, the interfaces change. So what happens is when interfaces change, then how painful it is for projects. Say, for example, if Hibernate is, interacting with struts and, in a model view controller scenario, and if you see that, the interfaces are changing, then again, you have to go back to the code and fix those interfaces. You have to go through the whole testing cycle. And that's a huge headache. We all know how painful it is. So that's one, issues we face. That's one of the issues we face. And another problem we see is that, a lot of plumbing code needs to be written. When you're setting up databases, when you are creating context, you are connecting to database, and then you are, maybe, firing, firing SQLs. So these sort of plumbing code, like infrastructure code or configuration code, that is a lot in Java, because if you worked on other languages, I think you will be able to appreciate my point. And if you have only worked on Java, probably you may not be able to figure out what I'm saying. But if you work on other platforms or other frameworks, you will probably see that the amount of plumbing code which you need to write in those platforms, it's much less. So I'll give you one example. Like if you're writing a servlet, and if you say, for example, you have a server which is running, any server which is running. If you want to write a Java client, which wants to connect to the server, it's a web server. It connects to a web server to fetch some data. Whether it's a browser-based client or a command line client doesn't matter, but the amount of work you have to do. You have to set up URL objects, you have to set up URL connections, you have to open a stream, you have to read the stream, close the stream. It's a lot of code has to be written. But if you're working on languages like Python, and you can use frameworks like libraries like response of Python, and you will see how easy it is. In 2-3 lines you can write the code. So that's one of the problems Java frameworks usually Java has, and that's anywhere, even in the Hadoop even in the Hadoop ecosystem. If you write a program in Java, probably that will be 50 lines, which can be written in Python in maybe 20 lines. Anyway, so that's the plumbing code problem which I was talking about. And so so because of these problems, we need to have frameworks and services which are easily maintainable, and we don't need to care about changing interfaces, so that integration is never a problem. And so in other words, basically I want the subsystems, like whatever I'm using in my application, to be loosely coupled. Like I want Hibernate to be loosely coupled with struts, and struts to be loosely coupled with, I don't know, maybe some other framework I'm using. So so that I don't have this pain of going through updating the interfaces whenever things change. So that's basically the problem premise, and the need is basically this. Okay, now changing interfaces. I'll tell you one problem. Say for example, this is a hypothetical scenario. Okay, we have Shashwata. He's asking a question that the changing interface issue. Can you give an example? Okay, I'll give an example, Shashwata. What happening is, say in the model view controller scenario. Don't worry if you don't know what a model view controller is. Just for the sake of the example. Say for example, you are interacting. You are from struts. Maybe you're calling some Hibernate calls, or it actually doesn't from struts. You can directly interface with the models. You don't actually call Hibernate calls. You interface with the model, and the model internally calls Hibernate. Now the thing is that in case the Hibernate API changes, which usually happens across versions. Now what happens is that you have to change your model, and if the change is dramatic, then maybe your model interfaces will also change. And if your model interfaces changes, the interfaces in the struts, that code also has to change. So the problem is, model abstracts. Model definitely abstracts, but the problem is that you have an abstraction layer called model, but still you have to go back and you have to change your model code. Okay, so that basically leads to this maintenance and scalability problem, because the problem is that's one of the major problems. And if the data types, or if the function signatures change, then obviously your model interfaces will also change. So here I have two scenarios, where the model code changes, and if this Hibernate signatures changes, then obviously the model abstraction interfaces also change. Are you convinced, Shashwata, what I mean by this thing? Are you okay with the answer? Okay, good. So I hope you have understood what I mean by it. So, and I'm sure as in your job capacity, I'm sure you should have faced this. It's a big problem for any person working in your capacity, to always have loose coupling. So I hope you all know what loose coupling is, and in case you don't know, don't worry, I'll show one example to you. Good. So so let's press on, and springtime. So how all these problems are solved. So after this chilly winter, we have springtime. So this person here, his name is Rod Johnson. Okay, he started a company called Spring Company, and developed the Spring framework for Apache in 2000. I mean, initially developed the Spring framework, and then he donated to the Apache Foundation in June 2003. And here is the project link. So if you click on this, it will take you to the Spring framework. Okay, And the latest version of Spring right now is what we have here is Spring 4.2.2. Okay, this is the last release, and I'm going to show you the demo on this. Okay, you can download that from the website, and it's just a jar, a zip file or a tarball, depending upon where you are. I usually work on Linux, but whenever I have such webinars, I have to switch to Windows anyway. So you can download the zip or a tarball, and you can just unzip that, and you'll get all the stuff here. So you have inside the docs, you have your Java doc APIs, you have your Spring Framework manuals, and inside the libs, you have around 62 jars. But out of that, all are not. Some are Java docs and some are source code. So you don't need actually. Libraries are 20 jars only. Okay, so there are only 20 jars, and the rest are all Java docs and sources. So this you have to include when you're running your Spring applications. And then here, basically, you have your schemas, your XSDs, which internally Spring Framework uses. These are XML schemas, XSDs, schema definitions. So that's about the Spring Framework library 4.2.2. That's what we have now, and you can download this from this link. Okay, and the thing is that Spring Framework, whatever problems I told you about, this interface problem, Spring basically encapsulates all these frameworks in itself. So even if their interfaces change or anything like that, Spring takes care of it. So, and it tries its level best to maintain the same interfaces so that your application remains pretty unchanged. So Spring Framework provides a lightweight solution. Well, actually, I won't say it is lightweight, because I see a lot of people on the web saying lightweight. It is really not lightweight, it's but again, it's not pretty heavyweight either. So it actually depends, what kind of applications you're writing. If you're writing pretty big, enterprise applications, obviously it becomes heavyweight, of course. But the framework itself, it's not a big pain. I'll show you when I use it. So we can call it a lightweight solution to maintain, to develop, maintainable and reusable enterprise applications. So one advantage is that the Spring frameworks encapsulates interfaces to Struts, Hibernate, Log4j, and Java server faces. And so the biggest advantage is that if internally these things also change, your Spring interface remains the same. So that's one advantage of loose coupling. So your application is not tightly coupled to Hibernate or Struts code, and you really don't care because you will just interface through the Spring framework. So that's one advantage. Shashwata, what it takes me back to your question. So that's how Spring solves the problem. So are you now clear? So basically we saw the problem domain, and we saw how Spring solves the problem. So do you have any questions, any thoughts you would like to share before I continue with the other slides? Do you have any questions for me? Anything you would like? Do you want to understand anything or? Okay, we have one question from Shashwata. He's asking that, so does Spring depend on struts? Spring doesn't depend, okay? There is no dependency, it internally encapsulates, okay? So if you don't want to use struts, you may not use struts, okay? But it doesn't depend, for Spring to work, it's not necessary, it has to have struts. So, struts framework is internally, encapsulated. So, if you want, you can use struts, or you get the source code from Spring, so you can do a Maven build where you don't include struts, that you can do those kind of things also. Okay, so these are not dependencies. Please don't misunderstand this. These are not dependencies on Spring. So these are things which are encapsulated. If you want, you can take it. You don't want, you don't take it. But Spring kind of, is not dependent on these. Okay. Thanks, Ashwata, for the question. Any other questions you have at this point? Okay, now we have a question from Hemant. So Hemant is asking, can't applications be built without Hibernate struts and only using Spring? Yes, why not? Why not? you can, these are things, it's not necessary you have to use this, let me repeat it again. These are inbuilt, that doesn't mean you have to use it. It's just like a buffet, when you go to a buffet, there is a 10 course, 12 course meal. Is it mandatory for you to start from the salad and end with the sweets? Do we do that? I don't think so. Some of us directly go to the main stuff. Some of us, who are on diet, skips, the desserts, and same shameless people like me, go and gorge on the desert. So yeah, absolutely, absolutely, right, Shashwat. So it's like that, So it's unnecessary. You have to use everything. It's like a buffet, which has been proposed to you, and you pick and choose what you want to use. Okay. Does that answer your question, Hemant? Okay. Yes. Thanks, Hemant, for your moral support on my weakness for desert. Thank you, Hemant, for that. Okay. Let's move on. Okay. So that's now we are going to discuss about the Spring architecture. This is what the Spring architecture is, and internally that's how Spring is assembled. Okay, and this is a runtime view. Okay, this is not a static view. So if you start the Spring engine, so these are the stuff you will have inside. Okay, and again these are all abstractions, and I'll explain to you what these abstractions mean. Okay. Okay, folks, let's start with the data integration and data access layer. So this is one subcomponent inside the Spring runtime. Okay, inside the data access and integration, you see submodules like JDBC. Now this module basically interacts with all databases. Okay, so if you are making JDBC calls like java.sql packages from your code, so Spring will basically use this component to directly connect to a database. And obviously you have to tell Spring which database you are using. Like you have to tell the driver location, like standard applications. If it's MySQL, you have to tell tell Spring, what is the driver class for MySQL, and the connection URL, password, etc. Okay, so this is a component which is used if you want to interact with JDBC. Okay, and let me show you one quick code snippet because you may be wondering that you have to write JDBC code from Spring. Here's one. I have a lot of samples here actually, which I keep using, but I won't have time to go through it here. So say for example, if you want to use JDBC inside Spring, okay, I'll tell you how simple it is. Okay, you just have to use this class, and don't worry about the code here. It's kind of a little bit teasing, saying implemented inner classes, anonymous inner classes, and all that stuff. But just this is the class you have to use. That's all. And this class internally, encapsulates all the JDBC calls. So of course you have to tell, about the driver connections and all those things through the data source. And this data source is again our plain vanilla java.sql data source. So that's all, and on the template you have wrapper methods like update and like query, things like that. So you don't have to make actual, JDBC calls. So that's one abstraction. Okay, good. So let's go back to the slides. So that's the JDBC stuff. Okay, if you want to interact with ORM tools like Hibernate or Ibertis, again, you have the ORM component which does that. And let me tell you how simple it is. If you want to interact with Hibernate, so all you have to do is you just have to use the Hibernate template, and that's all you have to do. And on the template, just call find. It's like a query. But if you're writing a Hibernate code, you have to do a lot of other stuff also, which Spring takes care of. So that's why I guess Spring is called a lightweight stuff. Okay. Similarly, you have object to XML mappers. So this is a wrapper for all JAXB, like Java APIs for XML binding. So this is what this component takes care of. This takes care of Java messaging services, and this takes care of all transactions with the database. So that's your data access. Now we come to the web part, the web module, the web component. Inside that, it has a subcomponent for web, for any kind of web related stuff like web server interfaces. It has a servlet interface to interact with servlets. Then it has a portlet, which is used for writing portal applications. Portals are basically single page applications which you write. And then it has a wrapper for structs. So just like Hibernate and JDBC, what you saw, if you have to use struts, you don't have to call struts APIs directly. Okay, so this is the abstraction. And in case, strut changes, you just have to get the latest version of Spring, and, these interfaces, they remain the same. So only the internal, things they change. So that's one abstraction here. Now the next layer we have is, to do with aspect-oriented programming. That's another key feature of Spring, which I'm going to talk about. And then it has implicit support for aspect-J. It's a type of programming language for aspect-oriented programming. And you have another submodule called instrumentation. This is basically for, any kind of internal diagnostics which Spring uses. And this is the core container. Okay, in the core container, you have, a bean container, and I'll show you what beans are. They are basically, where you create Java objects, automatically Spring creates if you annotate, Java objects as beans. So these are created and destroyed by the Spring framework automatically. So you don't need to bother about it. This is the core engine, core component, which is the whole, Spring backbone. You have a Spring context, which is basically the application context, which has all the runtime configurations. Because Spring basically, needs, configuration XML. So this is the context through which it maintains all the configurations. Well, you can do it through XML or annotations. Previous versions, supported XMLs, but with new versions, you can do a lot of, stuff, configuration stuff through annotations. And you have something called an expression language, which are Spring-specific expression languages. And then you have a test, a test module, which is a wrapper of JUnit. So if you want to use Spring, if you want to test Spring applications, you can use the test framework, which is again a wrapper of JUnit. Okay, so that's the architecture we have here. So do you have any questions on the architecture? Is it fairly clear how it works? Do you have any questions on the architecture? Okay, one more thing I wanted to tell you is that the Spring, this whatever PPT you are seeing will be shared with you. So this, and you will also get access to the video. So whatever I'm saying, you can go through it offline if you would like to see it again. And of course, the PPT will be sent to you. So any questions on the architecture, or can I move on? Okay, we have a question from Hemant. Hemant is asking that, he's saying that is Java, is Spring the most widely used framework? What about other non-Java frameworks like Node.js and Express.js? Well, Hemant, see, Spring is popular, and so is Node.js. Okay, so it depends on the choice of technologies which organizations or individuals have. But I cannot say that it's like a debate like whether Katrina Kaif is more popular or Karina is more popular. So it's a matter of personal choice, and so that's about it. Okay. And okay, now we have another question from Saurav Jain, and he's asking, can you please tell me about AOP and aspects? Yes, I'm going to tell you, Saurav. Just hold on to your horses. We are going to talk about that. So you will get, but obviously don't expect to learn AOP in this webinar. But I'll tell you what it is and how it happens. Good. So let's press on. So here we are, and now the two most important features, that is what I should call the spinal cord of the spinal cord of Spring are the two features are I'll just write it here. One is basically dependency injection. Okay, sorry, dependency injection, and another is called AOP. Okay, aspect-oriented programming. Okay, so this. Okay, by the way, do you all know what is inversion of control? Can I have a quick poll? Can quickly tell me what is okay? Quick, Deepak, Hemant, Kiran, Manjula, Nikhil, Saurav, Shashwato, Shivraj, Sonam, Shruti, Varsha, Vinayak. Quickly, what is, quickly tell me, it doesn't take even 2 seconds to write a yes or no. Then I can show you, okay, no problem. If you don't know, no shame, just tell me I don't know. No problem, it'll, because when you don't know something, it always gives you an opportunity to to learn it. Good. So I'll quickly tell you what inversion of control is. I have a quick demo which I wrote for a bloke, a few days back. He also had the same question. Look, the thing is that, inversion of control in simple words means, loose coupling. One of the biggest advantages of IOC, it's basically dependency injection is a part of, it's a specialized inversion of control. So here what happens is, it's kind of, a job interview scenario where, the interviewer will be calling the interviewee and not the other way. Okay, so it's like we will call you when there's a requirement, the standard answers. Okay, so here what happens is, through IOC we can achieve loose coupling. I'll give you one example. I have a silly framework here. I've named it a silly framework. The silly framework has two classes. It has a framework class and it has a framework interface. Okay. Now this framework interface in my silly framework has one method called interface method, and it has a framework class. Okay. Which has a public method called invoke framework method, and it has a constructor which takes a framework interface. Okay, and this framework interface, this reference is stored here and it is assigned in the constructor. So that's what my silly interface, silly framework does. Now in the application, I have an application which is using, this unfortunate application is using my silly framework, and what it has to do is, on based on some event or based on some callback, maybe this event, maybe this method is going to be invoked. So what happens is in my app, I implement my framework interface from my silly interface, from my silly framework. I interface this implemented, and so I override, the interface method. And in the main, what I do is, I create an instance of the framework class, and in the constructor I pass my application class, which is implementing the framework interface. And then on that, I invoke the method on the framework class. And what happens is in the framework class, in the framework interface, I have the reference to my app. So obviously, the my app method will be invoked. Okay. Now that's basically inversion of control in very, very simple words. Now in real life, what happens is, these things are usually fired through events, through triggers, through callbacks. So that's the firing mechanism. Since I didn't want to complicate my example, I basically just explicitly invoked it. But this can be invoked on some event or maybe on a callback. So that's an IOC. Okay. So let's move on. So this is IOC, and I hope this example was clear. Like, was it clear enough? Like people who are not aware of the IOC, like, did you get any? Did you now have some clue at least what IOC means? Can I have a quick poll? Okay. So just remember, it is basically the the job interview. It's basically a job interview scenario. We call you. You don't call me. Okay. So if you are selected, we will call you. It's like that. My silly framework class calls the app class and not the other way around, based on a trigger or event or callback, whatever. Okay, good. Let's move on. So what happens is, a dependency injection. Here what happens is, you saw in this IOC demo that, in my framework class, I was, I was taking a reference of framework interface and I was initializing it, and this framework interface was done from here. This main method did it. Okay, so I was instantiating a framework class and I passed a new instance of my app. Now basically dependency injection at runtime in Spring, if you're working on Spring, basically you don't have to do this. Okay, so this is not required. Automatically Spring will do this for you, provided you use an annotation here, and this annotation is called auto wiring. Okay, so I'm writing auto writing. Good. Okay, so if there's an annotation called auto wiring, if you use this auto wiring, automatically Spring is going to inject an instance of my app here. And obviously it's not as trivial as I'm saying, because what happens is, you have to do some other things also, which I'm not going to talk about, because obviously then I have to land up teaching you Spring. So that's one here. One feature is that you don't have to do this. Okay, and there are some annotations which you have to use here, and certain things you have to do here in the application, which will automatically inject this dependency on into the framework class. Okay, and that's dependency injection. Okay, and this is what my diagram explains. And don't worry, don't bother reading the slides. Just keep listening to me. I think that should be enough. Okay, what happens is this bean A, there's a bean A, which has a dependency on bean B. So it's like my framework class, has a dependency on my app class. And what happens is, through runtime dependency injection, my bean container in Spring is going to create this bean, and it's going to create this bean, and will automatically inject, based on the annotations I've done, the dependency into bean A. So as you can see, these beans are completely container managed. You don't have to bother about creating them, inserting them, again destroying them, when you don't need them. These are taken care by the container. And obviously the bean container can be needs a configuration file, but it's not necessary. You can do it through annotations also. So that it then provides, basically the advantages are it provides a consistent means of configuring and managing business objects. And objects created by so as I said, they are all managed by the container, and they are configured using an XML or annotations. So is this diagram clear to all of you? Like what happens here? So I don't expect you to understand 100%, but at least if you can figure out what the example I showed, and how Spring takes care of doing all this dependency injection, I think that's more than enough, because my job here is to ignite the curiosity, and then which will drive you to learn Spring. Okay, so that's the objective. Okay, the next one, the next most important feature of Spring is it has an implicit support for the model view control architecture. Okay, so what's the model view control architecture? Some of you who are from traditional computer science background, may have studied this. People who are not from such a background like me have found it out based on curiosity. So this is how it works. And this is an architectural pattern. Okay, never say that MVC design. MVC is an architecture. So what happens is you have three entities, three layers, basically three layers in your architecture: a controller, model, and a view. Now controller is basically the entry point for for all business logic. So what happens is you have a view here. So view basically it takes let me use a pen. I think it will be easier. Okay, I'll use a pen, and I'll choose a color. What color can I choose? I'll choose red. Okay, so what happens is all events come here. Okay, so all sorts of events come here, all requests, events, whatever. This can be over HTTP. Okay, it can be over HTTP. Okay. Okay, now I have to write HTTP with a pen, which is a terrible thing for me. Okay, I managed it finally. And then, or maybe on mouse clicks, if it's a desktop application. I'm not going to write mouse clicks now. Okay, so the request, the events can be from anywhere, and the view basically takes these events, requests, HTTP requests, whatever, and notifies the user gestures or whatever he or she wants, to a controller. So this is where the controller is the central point, where, and you can have many controllers. Don't think that it's one controller. It's a layer basically. Views are layers, controllers are layers, models are layers. So the view will route it to a respective controller. Now the controller is where you have all the business logic. So for the business logic, of course, it has to interact with the model to get the data, update data, whatever it will do in the model. And this is a layer again, which has which usually interacts with the database behind. It has the database or some kind of data store behind, or maybe a a JNDI data source, or maybe a file system, whatever. And this model is going to be updated with according to the business logic. And then basically the controller will notify the view that I have changed. And then what happens is then the view basically then reaches out to the model, and whatever changes has happened, it extracts from the model, and and then the view is refreshed. So this is the basic architecture of the model view controller, and that's how it works. Now, so is this clear? Is this model view controller clear? So this is an architectural pattern. It has, and these are all layers. Don't think these are classes or some packages or something. Okay. So can I have a quick poll on whether you've understood this or not? Okay, good. So here is a verbose explanation of or whatever I told you. So I'm not going to read this out. You can read it later on because I'm pretty bad at reading. So now we come to another important feature of aspect-oriented programming. Okay, and that's called of Spring, and that's called aspect-oriented programming. Okay. Now the thing is that when you write code, I'll show you some code which will really scare you away. Uh, uh, well, it won't scare you actually. Say for example, I cannot show you my production code for clients, but I'll show you some basic stuff. Okay. Okay. Race conditioning, inter-thread communication, deadlocks, rest condition. Now, see, here is a simple class I have. Okay. Now, don't worry, what this class is doing. But here, this class is using log4j, as you can see from the import. Now, what happens is, this class basically, is it's creating two tasks, two threads, and doing a bunch of things here. Don't worry about it. But in addition to what the threads are doing, this whole class is scattered with logs. Okay, there's a logger here saying, entering program, exiting program. Then here I'm saying, I'm doing this, I'm doing that, and this task is also doing the same thing. And again, if you go to another class, where the computation happens, there are a bunch of logs here. So, these are called cross-cutting concerns in computer science. Okay, so in addition to what the main logic, it is also doing some subsidiary auxiliary logics, like printing logs, or it can do other things like doing basic authorizations or authentication, or it can do some monitoring. It depends on the application logic. Okay, so these are called cross-cutting concerns. Okay. Typical case is generating logs, and I showed you one example. So it's like this, you have your code, which is your business logic. Just look at the diagram here on the right side. So you have your code, which is your business logic, and you have some cross-cutting concerns, like security-related stuff. You may have to do some logging. You may have to, check out, do some persistence here and there, and these are not related to the business logic. Okay, the business logic maybe just as I showed you in that thread, it was doing some processing. And now what happens is here, the problem is that in addition to the business logic, you have to also do these things, okay? Because if you don't do these things, you might get fired for not doing it. So these are called cross-cutting concerns. Now, what happens is when actually you write the production code, it kind of looks like this, So you have all your cross-cutting concerns scattered over the business logic. Now, this is basically a big problem, okay? Now, the thing is, with aspect-oriented programming, what happens is you can write the business logic separately and the concerns separately. And what happens is at runtime, okay? At runtime, okay? That's the beauty of aspect-oriented programming. At runtime, all these concerns are, are woven, okay? Are woven into your business logic. And this is, this in aspect-oriented programming is called weaving, okay? I'm sorry if my handwriting looks like that of a 2-year-old, but because I'm using a stylus pen. Sorry about it, I'm not that young, okay? So this in aspect-oriented programming parlance is called weaving, okay? So did you understand aspect-oriented programming? So this is kind of, aspect-oriented programming explained for dummies kind of, explanation. So this is all it does, This is all aspect-oriented programming is. And then you can get into a lot of complications, defining point cuts, how to intercept, all these things. So somebody had a question on AOP. Yeah, sort of, Jen. So is this clear what AOP is? This is all it does. At runtime, the aspect-oriented engine basically, weaves your cross-cutting concerns into the code and generates the bytecode, and this bytecode is executed. Is this clear, Saurav Jain? Okay, we looks like Saurav Jain is okay. Anyway, let's press on. So that's called weaving, okay? And what happens is this is what aspect-oriented programming does. And there are also a lot of other complications which you can handle, like when it is how do you insert the cross-cutting concerns. You write something called interceptors and filters through which you can intercept, and you know exactly when to log. So say for example, you might ask that, okay, I am supposed to log here, but how will I tell AOP that I have to log here? So those things you can actually do with something called point cuts. So you can define point cuts, and not in the business logic, separately, where it says that at exactly this point after this function call put a log. So these are called point cuts which you can do in AOP. So that's what AOP is. Okay, now are you able to appreciate what AOP is? And so is this clear what how Spring handles AOP? And so this implicit support for AOP is already there in Spring. Okay, Spring has its own interfaces through which you can do AOP. Is this clear? Can I have a quick poll whether this is clear to all or not? Good. Thanks for your acknowledgement. Now let's move on to Spring Big Data extensions. Now Spring Big Data for big data, Spring has two frameworks. It has something called a Spring Extreme Data. So Spring Extreme Data is a framework which you can actually deploy on a Hadoop or Yarn cluster. So you can deploy it on a Hadoop cluster, or you can deploy it on Apache Mesos or Amazon E3. So you can deploy this on distributed file systems, and the Spring HD, this extreme runtime has interfaces for streaming data and for running scheduled jobs on Yarn or Splunk, Mesos, any kind of DFS cluster. And this clusters internally, they can. It has also features to export this data to RDBMS or NoSQL or R or SAS jobs, and it can also dump into in-memory databases like Redis. So this is all this is the kind of high-level architecture it has. And so basically it has data ingestion through streams or jobs. It can pump, or it can listen to streams, and it supports real-time analytics by interfacing with underlying engines. It can do job processing through jobs, and it can also export data to other databases. So it can extract data from HDFS, and the results can be dumped to RDBMSs or NoSQL databases. So that's the Extreme Data Framework. And there's another project called Spring Data Projects. If you go to this link, you will see a list of Spring interfaces, Spring extensions for this big data ecosystem. So it has a common module, which is basically needed for all. It has a JPA, Java Persistence API module, to interact with RDBMS. It has a MongoDB extension. So if you want to, from Spring, if you want to interface with MongoDB, you can take this module. If you want to interface with Redis or Hadoop or key value databases like Neo4j or with Solar. Solar is a search, a real-time search engine from Apache, which works on the Hadoop ecosystem. It also has REST interfaces. Okay, and community modules are basically not supported directly by Spring, but by these companies who provide Spring extensions like Cassandra, which is a column-based database, and Elasticsearch and Neo4j. So these sort of extensions are available. You can use them, and so that's about the big data stuff. And here we see the job trends. So we see that how jobs demands are there in terms of growth. comparing J2E, EJB, and Spring. You can just go to Google Trends. You can just see the latest data. Okay. And now let me show you one demo. It's a Spring-based web application I'm going to show you. So what it has is, it has a typical model view controller architecture. So what happens here is, you get an incoming request. It goes to a dispatcher servlet, which is internally there in Spring. You don't have to do anything. This is there in the Spring engine. And, this dispatcher servlet routes, this particular request to a respective controller. And this controller then, as per the MVC architecture, updates the model and mentions the view name to the dispatcher servlet. So then the dispatcher servlet, basically takes, the model data and the view name and passes it on to the view resolver. So which basically finds out, where the view is and accordingly invokes the view, and through the dispatcher servlet sends the response. So that's what the architecture is, and I'm going to show you a demo on this. Let me start my Apache, and so what happens here is, I have a Spring servlet here. So what I'm doing here is, I have a servlet. Okay, this is my controller servlet, and this is the stuff. This is my controller, and that I annotate, through the controller, annotation. And here I say that, the request mapping is, /echo. That means whenever I give a path /echo, so it will map to this controller in the servlet. And so I don't know whether you know servlets or not. But if you don't know, then maybe you will find this code difficult to understand. So, and then you have the request parameters, where I say, what is the parameter value, like what is the parameter name, and what is the default value. That means if I don't give anything, then what is the value? And then I take this, parameter values, and I set it to the model. And I also return the name of the view. And I am using a view called echo.jsp. So in the echo.jsp, basically what it does is, it just prints that name. And, I have a web.xml where basically, I just define the dispatcher servlet, which is the entry point to the code. And I have a Spring servlet, I have an application servlet XML where I define a bunch of things, like I have to tell the Spring that which is the module, which is the package which needs to be scanned to find my controllers and relevant classes. And I also tell the view resolver, this one here, this view resolver, that where to find my views. I have to tell him, right? It can't just keep searching. So I tell him that, look into my, root folder of my web application with, JSP, extensions. And basically what this application does is, I'll just show it to you. If I go to, localhost, and I do, Spring servlet echo. So basically it says, wake up Prithviraj Bose, okay? Because that's what it does, and that's what the JSP does. Wake up and the name, it prints a name. And since I didn't pass any name here as a, as a query parameter, so it printed the default value of Prithviraj Bose. Now, but if I give some value here, say, if I give a query string here, say, name equals, I don't know, maybe Johnny or, John. So it says, wake up John. Or if I say, Johnny, it says, wake up Johnny. Or if I say something else like, maybe, it says, sorry, I meant Johnny Handsome. So it prints, wake up Johnny Handsome. So, so when the name is passed, this goes as a query string. And this is a simple example of how you can do servlets. And if you look into this example, you can see how obscenely simple it is. That's all the code is I have to write. And in the JSP, just one line of code. And in the controller, that's all I have to do. But if you had written a servlet, I think you have to write a little bit more code than this. So a lot of things are taken care of, by the Spring framework. So that's one advantage of Spring. I'm not going to explain you the code because, obviously you don't know what Spring framework is. So, explaining the code to you won't be of much use. So that's what it does, So dispatcher servlet is already, an inbuilt servlet of Spring, which it uses to interface. as an entry point to any application, web application, I mean. Okay, two XMLs are written. One XML is basically is needed for the web.xml, which you saw here. This will be needed for the web server, okay? Because the web server need to deploy the servlet. If it doesn't deploy the servlet, if it doesn't find the servlet, the web server cannot deploy it. So this is required for the web server. And this XML, it's basically the application name -servlet.xml. This is required by the Spring container. Okay, is it clear, Nikhil? So because the Spring container has to know, which packages to scan for the classes, where to look up for the views, so that the web server doesn't care. I have to tell Spring. Is it clear? Good. Okay, so there we are, and so now we have a course from from edureka, which is called Spring Framework, and it's starting in the 19th of December. It's a weekend batch, and these are the highlights of the course. It'll cover all the basics of Spring, and starting from dependency injection to integrating Maven, because these days all builds are done through Maven, all Java builds are done through Maven. It will teach you aspect-oriented programming, integrating Hibernate with Spring, building apps with Spring MVC architecture, using Apache tiles and JSF for making views, and also making it secure, and using Log4j as a logger, and how to write Spring test cases using JUnit, which has a wrapper, as I told you. Now, at the end of the course, you will also create a web application using Spring, and you have online live courses. Well, the course is not for 24 hours, of course. I mean, the course, you have access to the LMS for 24 hours. That means you can access your modules anytime. You have 20 hours of projects, and assignments are worth of 25 hours, and you have lifetime access to the material. Okay, so that's the course, and recording and the presentation will be sent to you, as I had said. Okay, now question time. Tell me what questions you have for me. Do you want to ask anything? Because that brings us to the end of the webinar. So I want to just ask one question to all of you, that did you find it useful? Because you spent 1 hour with me. So how was it like? Could you please tell me, could you please summarize in one word, how was your experience in the last 1 hour? Deepak, Hemant, Kiran, Nikhil, Shashwata, Shivraj, Shruti, Varsha, Vinayak. Can I have a quick opinion about? No, okay. Shashwata has one question that okay. First question from Hemant. He's asking that will you be the instructor for this course? The short answer is no. And the probabilistic answer is maybe, but certainly not for 19th December, because I'm not available. So that's the reason why I'm not taking this. Maybe the next one I'll be taking. Okay, but actually these days I'm a little bit busy with with the big data stuff. So anyways. So but don't worry. Whoever is there will do a good job. Okay, right. And okay, Shashwata has a question. Do you use Spring tools or Eclipse with Spring plugin? Well, all I do is I just include the Spring. If I'm using Spring, Shashwata, what I do is I just in the build path I include my my Spring. Gosh, where did it go? What I do is I just include my my jars. That's all I do. And if you're building a Maven, you have to create a Maven dependency project. Okay, so that's how you go about doing it. Okay, next question I have is, and okay, I think I have answered. Shashwata, I've answered your question. Yes, and well, usually what I do is I use this Maven plugins to for this. For building, I usually don't include, all this, mumbo jumbo. I don't do here. I showed you, including the jars in the class path. I usually don't do, I do a Maven project and give the Maven coordinates for Spring, and automatically it builds, So that's how I ensure that I'm always on the latest. And so that's how I do it, So I use basically the Maven plugin and use the Spring, coordinates for Maven. Shashwat, have I answered your question? So that's how I do it, but it depends on your choice, as long as whichever you're comfortable with. Okay. Okay, there's one question from Vinayak, maybe that will be relevant for all of you, is that, what is the level of Java programming required to get into Spring? Because he says, he's able to appreciate AOP, he does understand AOP and DI, because he has used them in .NET, C#. Well, Vinayak, for you, it's going to be a cakewalk, it's not really a big deal, because if you already know AOP DI, if you've done coding in C#, which is the syntax is very similar to Java. So, I don't think you will have any problem at all. So give it a shot, please. Okay, so, Hemant is asking, is there any good resources to start with Spring in addition to the courses? You can go to the Spring site, the URLs are given there in my PPT. So you can visit that, and you can see, if you go to the resources, you will see lots of, nice articles and blogs and tutorials. You can go through that, because Spring is really big. It has a lot of facets, like the view part. On the model, it has Hibernate, Ibetis, ORM interfaces. With XML, it has JAXB and other sorts of things. Then if you come to AOP, it has Aspect-J interfaces. So it's very difficult to learn everything in one shot. Maybe you can try with things you are comfortable with, and gradually go forward. Once you build your confidence, you can maybe challenge yourself with something new. Okay, good. Now, I have one more question. Can you elaborate, from Shivraj, can you elaborate more on expression languages now? Well, expression languages, Shivraj, they are mainly used, say, for example, it's more similar to, what should I say? One sec, let me find a good example of, expression languages, so that, what can I say? Say, for example, so let me think. Something, which is, easy for you to understand, because otherwise I don't want to get into, say, maybe one example is, if you create, say, series of beans, Java beans, what happens is, say, for example, you have created a Java bean, okay, a bean in Spring context, and you have created some other beans also, which are inherited from that particular bean. Then what happens is, inside the Java, inside the JVM, these are basically acyclic directed graphs. Okay, these are called DAGs, directed acyclic graphs. So, if you want to traverse the graph, you basically have to use, it's like a path expression you use. If you want to go from object A to object B, you maybe have to go through object C and D, and you can actually give an expression. So there are, standard classes for it, like expression parser, expression builders. So you can actually go to that particular object using path-like reference, folder-like reference, and do a get value. Okay. So that's the most simplistic example I can give you, because expression languages are a little bit difficult, to kind of explain in 1 minute. So that's why I just quickly thought of an example. But if you go to the Spring resources, you can see good examples there. It's very similar to what I've told you. They have some more complex stuff, but honestly, I don't see people using expression languages, at least in projects I have not seen. Okay. So have I answered your question? Sorry, Shivraj, have I answered your question? Because it took me some time to go through questions, one at a time. Okay. Okay, I think I've answered Vinayak's question. I've answered Hemant's question. I've answered Shashwata's question. Okay. Good. So Shivraj, I'm sorry, I just gave you a very short answer, but this is just the overview, because in 1 hour, as I told you, Spring is huge. I cannot tell you Spring expression language in 1 minute. It's one of the most advanced concepts of Spring, and so maybe you have to really be a good master. You have to understand a lot about directed acyclic graphs, about object graphs. Once you really understand those computer science fundamentals, then only you'll be able to work with expression languages. Okay. So that's about me for that's about it from me. So what we'll do is if you don't have any questions, we can end the seminar. We are already 10 minutes past 10:30. So thank you very much all for your time into it. It was really nice to be here, and I really like the questions. The kind of questions which was asked. I really enjoyed. Okay, being a part of this webinar. So good luck to all of you, and I hope you can fall into this. You can start off Spring and master it. But it will take you a couple of months actually. If you it will take you at least 3 to 4 months. To really be good at Spring. So just give it a shot. Okay, thank you very much. And have a good night to all of you, and good night, or if you're in the United States, maybe good morning. Have a great day, and see you then. So I'm ending the webinar.